A while back, when we first started doing two unknowns, we looked at this program called Family of Functions to sort of get an overview of what was to come. Let's look now at the family that's the quadratic family, because that's the one we're about to get more familiar with. We're not linear, not constant, not absolute value, but quadratic. So let's go on with the quadratic. Choose a family of quadratics. Now the quadratics all look like this. This thing, y equals x squared, is what we call the parent function for the quadratics. When x is 1, y is 1. When x is 2, y is 4. You can put 2 in here, you get 4. When x is 3, y is 9. You can see this shape. Now if we change some of these numbers, like change this to a 2, you can see that when x is 1, y is 2, because 1 squared is 1 times 2 is 2. It makes this skinnier. Let's see if we make it even bigger. It gets skinnier still. If it gets negative, it gets upside down. Now if we put these other numbers in, they move things around, but not in any readily discernible way. What happens is that the mathematicians found a form that if they factored this in a certain way and got it into a particular form, I guess it took them a few years to figure it out among themselves, that we could look from the equation to the graph and see the continuity. This is what we're going to look at. I'm going to close this program right here, and we're going to go back to the main menu, come to our x squareds, and go to graphing quadratics. This is the form that the mathematicians found was useful for being able to see a connection between the graph and the equation. This is a graphing form. We sometimes call it like a graphing form. So, but let's look at it. It's y equals, A stands for any number, like 1, 2, 3, 4, 5, negative 16, whatever. X is the x of our equation. H is another number which is going to cause a shift in our graph. And K is also another number. Let's see what happens. Right now we're seeing nothing because we see y equals 0 times everything. What you're seeing is this blue line. Nothing is there. In order to get the simplest parabola, we're going to have at least some number out in front. And here's the parent. Y equals 1x squared. Y equals 1x squared. This is the parent of all parabolas. Now we could change the value of this k down here at the end and watch what happens. Oh, if we change it, it drags the parabola up. And it drags the parabola up by the amount that this k value changes. Drags it down. Well, if that's what that number does, let's see what happens when we change this 1. What if we change it to a 2? Oh, then when x is 1 unit from the vertex, this place right here, the most important place where it turns around, is called vertex. When x is 1 unit away from the vertex, it now goes up 2 instead of 1, like it did when we were at 1. Wonder what happens when we take it to 3. Oh, 1 away from the vertex, it crosses at 3 and 3. This controls how steep our function gets. What if we go negative? I bet you can guess already. If we go, oh look, when it gets to be like a 4th, it gets fat. When it goes negative, it's upside down, 1 to the right, down 1. Let's go back to positive 1. The parent function. We know that this drags it up and down, and this one, let's see what it does. Oh, I put a negative 2 in here, and look, I have a negative 2 in here, and it moved 2 to the right. Wonder why that is. Put a negative 2 in there. Doesn't seem quite right. You'd think it would go to the left. But the real reason is because if x minus 2 were set equal to 0, to become the 0 of it, then x would move 2 to the right. One of our teachers said this is always going to be backwards from what you think it should be, at least at first, and he called what happened inside this quantity the bad dog. Like if there's a negative 2 in here, it moves 2 to the right. If there's a positive 2 in here, it moves to the left. So let's minimize that and see. If we go, look, it keeps, with all the negatives, it keeps moving to the right. If we go to the positives, it's moving to the left. Let's go back to the parent. And this one, he called this the bad dog, the one that's locked up in the fence, because it always did the opposite of what you might think. But this one is free to roam, because if you say 5 to him, he pulls it up 5. If you say negative 5 to him, he pulls it down 5. Now we're ready to play a game, ready for questions. I'm going to give you a problem, and it's going to be a graph. And we want to see if we could tell what this equation should be to give us this graph. The vertex is not on the origin like the parent function is. In fact, it's 1, 2, 3, 4, 5, 6, 7 to the right. That's the bad dog, left and right. So I need a negative 7 there. And it's 1, 2, 3, 4, 5 up. 1, 2, 3, 4, 5 up. If I put a 1 here, that'd be the shape of the parent function. Let's check and see. Oh, look. It's at the right vertex, but something's not right. It's supposed to be upside down. I hope you can yell at me. It had to be negative, didn't it? Oh, okay. So let's make it negative. And now check. But it's the wrong shape. Pretty close, but it's not the right thing. Because the one that I drew was 1 to the right, it went down 1. And the one that we have goes 1 to the right, it goes down 2. So it didn't need to be negative 1, it needed to be negative 2. Betcha now we can win. Watch. We are correct. Let's do a new problem. Does this function live at home on the origin? No. He's moved in the x direction 1, 2, 3 to the right, which means he's the bad dog. We need to move negative 3 in here. In north and south, he's moved down 2. What's his shape? If we go 1 to the right, he's just gone down a little bit. I think it's negative 1/4, negative 0.25. Check, we win. New problem. Oh, finally one positive. Does he live at home? No. His vertex is moved 1, 2, 3, 4, 5, negative 5. So I will put a positive 5 in the bad dog slot. He's moved 1, 2, 3, 4, 5 this way. Negative 5 in the good dog slot. What's his shape? If we go 1 to the right of the vertex, we have gone up 2. So we need a 2 there. Let's check. I betcha we win. Oh, let's just put a 1 there just to see. Oh, see, it's not right. See, 1 would take it here. We need to take it up to 2. So let's go like we said. Check, we win. New problem. This will be the last one, and I hope you can solo flight on figuring out graphing quadratics in this fancy form. And you need to memorize that form. A, x minus h, the quantity squared, plus k. You need to memorize that form. Y equals a, some number that controls the shape, parentheses x minus h, the h controls horizontal movement, squared, plus k, which controls vertical movement. Memorize it. You will use it your whole life if you want to be in anything related to math. And I hate to say this, but mathematicians get paid more. So, except if they're teachers. Okay, this vertex is not at the origin. In fact, it's 1 to the left. So the bad dog is 1 to the right, plus 1. It's down 3, so I'll come down 3. The shape is just a quarter, so I'm going to come to a quarter. Check, we win. hope you get this. Get really good. There are other parts to this program, but I will record those in separate things because this skill is enough for you to learn today. Learn it now. Get good at this form of the equation. Thanks.